So hello, everyone. Welcome. Thank you for joining us today. My name is Dave Donaldson from MIT, and along with David Atkin from MIT, we've been asked to put together on behalf of IGC and BRED a sequence of PhD level lectures on the topic of firms and development. And we're delighted you could join us here today. I just want to advertise before we go any further that we, this is lecture number 7 of 8, and we have recordings, slides, reading lists for this lecture, as well as all previous lectures and then the subsequent lecture taking place tomorrow, all on the IGC website. And there's a link to that in the chat below. So today our lecture is going to be given by Lauren Bergquist from Yale. Lauren needs no introduction. She's written seminal papers on the topic of today's lecture, which is going to be sort of broadly markets and competition. We think this relates to the lectures you've hopefully already seen, but can again see on the website if you've missed any, that sort of paint various pictures of misallocation of economic activity in developing countries, in particular across productive activities and hence firms, and how that could be a source of underdevelopment. And today the theme is sort of competition and lack thereof as one possible source of such misallocation. So we'll start very shortly. I just want to point out that panelists, you're welcome to raise your hand and ask questions. Lauren, and ask those out loud when called upon. Lauren will also try to do her best to pause occasionally to invite such questions. And non-panelists, that is everybody else, feel free to just write your questions in the Q&A box, and we'll do our best to try to find moments where we can intervene and ask those questions out loud to Lauren. Anyway, Lauren, that's all I had to say. Please take it away, and thank you so much for joining us, Lauren.
Great. Thanks so much for having me, and thanks for that kind introduction, Dave. It's really a pleasure to be a part of this course. It looks like it's been a really fantastic one so far. So thanks for including this. So let me give you sort of a high-level agenda of where we'll be headed today. So we'll start by talking about just sort of understanding the landscape. So you've heard a lot, I think, both in Dave and David's lectures about sort of the overall landscape of what firms in developing countries looks like, and then you've heard sort of in your courses since then. So I want to talk just overall about kind of the factors that might hinder and might support competition in low and middle income countries. Then we'll move kind of from the theoretical factors to the measurement side. So how do we actually measure competition? I'll talk about some of the traditional approaches sort of in the non-development literature, and how that might be potentially, there might be potential challenges, but also opportunities in applying that to the low and middle income country context. And then we'll get into sort of experimental approaches, including some work of my own with Michael Dinnerstein in Kenya. The third section will focus on implications of competition on a variety of outcomes, including firm selection, meaning sort of entry and exit by firms, prices, quality, and contracting. I'll spend the most time here in this Jensen and Miller piece, and if we have time, we'll go over sort of briefly these other pieces. I know that Rocco, I think, covered a portion of this last piece on contracting in the most recent lecture. And then, of course, I'll conclude by talking about sort of opportunities for future research in this space. So I want to start by kind of, again, understanding sort of the lay of the land and talk about factors that might either limit or support competition in low and middle income countries. So let me start with a question to the panelists, and you're welcome in the Q&A to also add responses if you'd like. Thinking back to, again, that kind of lecture 1 description of what it looks like for the market environment for firms in low and middle income countries, what are some of the factors that you think might potentially hinder or limit competition in this environment?
Should we just unmute ourselves and
Please
talk?
do. I actually can't see everyone at once, so please do feel free to just jump in if you can.
Okay, so sorry if someone raised their hand. Anyways, I don't know. I would think that maybe these markets are kind of characterized by few very large firms, potentially kind of state-owned enterprises, this kind of thing, crowding out, let's say, smaller firms.
Mhm. Yeah, so you could see there being very, very few firms. And then there's a second question of why are there very few firms, right? So maybe there's sort of regulatory barriers by the states in terms of which firms can enter. That might crowd out other potential entrants, and fewer firms might mean less competition. Absolutely. How about some other reasons?
Access to capital for startups.
Yeah, access to capital, right? So there's potential entrants who might want to enter into the industry, but can't because of all the kind of typical, credit constraints that we think about in developing countries. That might limit the number of entrants into a market and thereby limit competition. Great.
Yeah, perhaps on the other end of the spectrum of what Pietro was saying, small firms, but that are kind of parsing up the market into very specialized goods. Maybe we at first look at them as they're all fruit vendors, but they're all kind of specializing. And I've got the tomatoes cornered and you've got the apples and stuff like that.
Totally. Yeah. Defining the market's going to be a really critical component of this. So it might look like a big market, but when you think about the actual relevant markets, either by product or by geography, it might actually be much smaller. There might be much less competition in that area. Any other ideas?
Information available to customers on finding alternatives.
Yep, absolutely. So search costs, information frictions can limit, again, sort of the size of the market, right? So you might know about your local supplier, but you might not know about others. And that will come up a lot in this Jensen and Miller piece. So these are some great explanations. Let me kind of go through my own list, which I think covers a lot of what you all discussed and is by no means comprehensive. But the first is this idea of sort of a smaller market size, right? So this has to do with the variable profits that are available to support firms, right? So, if you're in an environment with a small market size, it's harder to support a large number of firms in the presence of there being fixed cost. And here, I think you already got it. Some of these smaller market size can mean a couple of things, right? Of course, it's going to mean just population, number of consumers. It also can mean, the ability of consumers to purchase. So poorer consumers. And it can mean to sort of the segmented kind of markets, again, we talked about kind of information frictions, also physical trade costs and the like, right? So this all sort of means, again, lower variable profits, which means fewer firms can be supported in the presence of fixed cost, which can mean lower competition. There also could be greater barriers to entry. So you mentioned some of these as well. The first, of course, is kind of legal or regulatory barriers to entry, right? So maybe the state has regulation over who can open a business in certain industries. The World Bank has a great sort of doing business indicators where you can look and see by country the particular barriers to entry. There also could be sort of, outside of the legal realm, there could be essentially illicit barriers to entry. So think about corruption and bribes. So, maybe it's not just that you have to fill out very extensive paperwork to become registered, but you also have to, on top of that, pay a bribe to the official, right? You could think of that like a sort of second barrier to entry. I will say there's a little bit of sort of, I think it's sort of open question as to whether competition is an additional barrier to entry on top of the red tape, or whether it actually is acting a little bit like a substitute to actually say, well, if you can pay a bribe instead of filling out the paperwork, that might actually lower kind of the barriers in practice, right? So some debate there. But then, of course, I think this was mentioned in the answers here, which I think is a really big one. It's just these kind of de facto barriers to entry. So credit constraints, right? There might be entrepreneurs who have a great idea, could open a very profitable business to compete with incumbents, but don't have access to working capital. Okay, so those who are able to enter then are the folks who already have access, maybe those who are wealthier to begin with, and that's a smaller pool. So you have fewer entrants. Okay, so these are sort of the factors that determine the number of firms, smaller variable profits, higher barriers to entry. There's also a matter of how those firms interact, right? So I think you talked last week about contract and relational contracting. In the presence of other market failures that we think are sort of specific to or are common in low and middle income countries, like, for example, lack of kind of formal contract enforcement. Relational contracting, as Rocco talked about, can be sort of a substitute for formal contract enforcement. But sort of the flip side of that is it means you're in sort of a captive relationship, right, between a firm and its consumers, or in the case of monopsony power, between a firm and producers. And that can limit competition, your ability to kind of go outside that relationship to find kind of competing offers. Okay, so these things can be deeply sort of entwined. Okay, so these are all factors that might make you think the degree of competition among firms could be quite limited in the low and middle income country context. On the flip side, there's reasons to think competition could be quite high. So what are some of the features of that environment that you think might support competition or make you think actually competition could be quite high in this environment?
The presence of many, many small firms.
Yeah, exactly. So there's many, many small firms. And so, you know, why would that be?
Lack of differentiation and return to scale convexities.
Yeah, so there could be just kind of structural things to do with the industry sort of specialization that you see common in low middle income countries. So as you said, there could be industries that sort of don't exhibit those scale economies. Or there can be kind of limited product differentiation, and in which case, you know, you're sort of all competing over very homogeneous goods. Absolutely. Other thoughts?
Close to subsistence, I guess the outside option is pretty low, so you're willing to go quite low in your price, as is everybody else.
Mm-hmm. Yeah, so maybe sort of desperation and subsistence kind of leads to kind of greater competition. So it could be harder to maintain collusion, for example, if you're really desperate for that additional dollar as the business owner. Absolutely. Other thoughts? Okay, let me give you some of my list here again, which some of these were covered. So yeah, so specialization in industries that maybe don't feature strong economies of scale. So thinking about sort of, you know, cottage industries. Agriculture is potentially a big one. So, you know, the most common firm in developing countries is a farm. I will say there's debate here as to whether there are scale economies in agriculture. The most recent paper in here that's pretty fantastic is by Andrew Foster and Mark Rosenzweig. But you may imagine these are in general, you know, industries where there aren't strong economies of scale. Okay, and just to play that out, what that means is you're not going to have kind of these natural monopolies that might emerge in an environment that you might have with, you know, with strong economies of scale. Similarly, this was mentioned, you know, maybe lower degree of product differentiation. Okay, and that can come both kind of on the supply side, so specializing in commodities or very homogeneous goods in which we might naturally think competition is quite high. As well as from the demand side, right? So poor households might be less willing to pay for quality, and so you just have less differentiation based on quality measures. We discussed, you know, barriers to entry and the fact that they might legally be higher in some developing countries, but of course there also might be less enforcement of those barriers. So, you know, I think it's quite clear when you look at, say, the large informal sector, right, that maybe there's greater red tape to opening a business, but you don't necessarily need to register your business to operate. And so you can have an environment of many small informal firms that are increasing the competition in the market. There's also, depending on the sector, you know, sort of relevancy here about thinking about limited sort of IP protection, right, that might otherwise prevent sort of copycat or generic production. And then finally, and this is sort of a nuanced point, but I think is maybe a fruitful area for future research is, you know, these de facto barriers like credit constraints that we talked about being a barrier to entry, they're also a barrier to firm growth, right? And so it's possible if they're constraining growth more than entry, they might actually serve to maintain a market of many small firms, right? So, you know, I think the microcredit literature is sort of supportive of this point in that it seems like when you alleviate, you know, these barriers, these credit constraint frictions, it doesn't do a whole lot to help people open new business. It really seems to be most effective at kind of the right tail of already profitable businesses. So you might find if you were able to alleviate this credit constraint that we think sort of proliferates in low and middle income countries, you wouldn't see a ton of entry, but you actually might see the existing firms, the very profitable ones, grow quite large. That might actually limit the degree of competition. Could still be very positive for productivity on the whole. Okay, I'm not saying it's not a good thing, but thinking about its interaction with competition, I think is fairly nuanced. And it really depends on sort of where along the distribution of latent productivity that constraint is most binding. And so I think this is an area of potential future research. Questions on that before we go on to kind of measurements? Okay, so let's turn to measurement. I want to talk first about kind of some of the standard approaches to measuring competition, measuring markups. And I want to talk and highlight about how these approaches can be potentially, particularly challenging or particularly fruitful in this development context. So we'll go from kind of easiest to most complex. So the first thing you could do if you want to sort of measure are firms competing, colluding, is you could ask them. That might sound crazy, but actually prior to sort of the antitrust legislation in the US, US firms used to fairly openly discuss, for example, price setting and price agreements. And there's sort of this long history of the IO literature that actually uses minutes from board meetings to identify periods of collusion and periods where collusion broke down to study sort of pricing decisions under these two regimes. So you can imagine, in the development context, we run surveys, we talk to firms quite a bit. You could just ask, are you competing? Are you colluding to set prices? How are you setting prices? So when you think about this approach in the context of, doing this in developing countries, what do you see as sort of the pros and cons overall, and then in particular with development? Everyone thinks it's a fabulous idea. We should just stop here. What are the pros and cons?
All right, I guess I'll try to answer.
Look you out.
So the cons, obviously, of asking firms, are you colluding? I mean, I don't know much about this. I've never run a survey, but I don't think they would be very honest, but I don't know. That seems pretty obvious to me. Kind of more difficult to think of pros, but.
Yeah, so, I think the pro, or the relative pro, I will say, is that, in many low and middle income countries, there tends to be a weaker antitrust regulation, or at least enforcement. And so you might find firms at least more willing to openly discuss. But of course, as you say, there's still going to be these strong social norms against collusion, and that's going to clearly drive self-reporting bias. This is actually a quote from the paper that I'll describe in just a moment that I worked on with Michael Dinnerstein. And, we directly asked traders, actually. So this is working with agricultural traders in Kenya. I'll tell you much more about the context in a moment. We directly asked, do you have a price agreement with other traders in this market? And what we found is that, only 30% report engaging in explicit price agreement, but 72% of traders work in a market where at least someone else told us in that market that there was a price agreement. And typically they say it's with everyone else in the market. So, I like this because it highlights, I think, two things. The first is that you actually can learn quite a lot about the environment through talking to firms. Okay? So I just want to emphasize there's a lot of qualitative work that goes on behind the scenes behind these papers that doesn't show up necessarily in the paper. And I would really encourage you, if you're doing especially sort of field work in development, to talk to firms and ask them if, of course, it feels both safe and appropriate given the context. But this also, of course, highlights the issue you mentioned that, of course, there's going to be very strong reporting bias. And I don't think anyone would believe this to be kind of a credible way of measuring competition. But I do want to encourage you all to do kind of the qualitative work, again, with the caveat of being both safe and appropriate for the context, but to actually talk to firms and learn what they say about sort of how they're interacting with each other. Okay, but with the understanding this is not going to be a convincing method, what are some more quantitative or more convincing methods of measuring competition? So the next sort of most straightforward thing you could do is you could use accounting data to estimate markups, right? So, in theory, prices are typically observable. You could get accounting data to estimate marginal cost, and then you can look at the difference and estimate markups. So what do you think are the pros and cons of this approach?
It's going to be hard to get good data. And
yeah, right. Yeah, so that's a big one. So I would say, in general, even putting aside kind of the low and middle income country context, this is generally not a super popular approach because, it's hard to estimate, first of all, the value of capital in particular. So many inputs, but in particular, capital is very hard to value. It's hard for multi-product firms, which a lot of firms are, to assign costs across products. And then you mentioned, I think this is certainly true. This approach is probably even harder in the development context, right? So, many firms don't keep records. In fact, there's this whole literature on how do we convince firms to keep records. And so I think, for the development context, it's not just the value of capital, it's even the value of, materials and labor that can also be hard to measure. The other sort of limitation here is, imagine there's perfect measurement, you might find large markups and that might be suggestive in perfect competition, but without knowing more about the feature of the market, in particular, without knowing more about demand, you can't run counterfactuals. So you can know what markups are currently, but it's difficult to know, what would happen to markups if you had, say, greater entry or greater competition. So this is, I think this is more appropriate as a sort of outcome measure if you already have an experimental variation or you got sort of a quasi-experiment through a policy shock to use this as a measurement of an outcome of markups, with all the caveats that I mentioned about measurement. But it's not great, for example, for running counterfactuals like the kind that we'll run, for example, in the piece that I'll discuss in just a bit. Okay. So in recognition of some of these measurement challenges, an approach that's sort of grown in attraction is this idea of cost minimization, or basically kind of a production function approach. And the basic idea here is that if firms are minimizing cost, then for any one given flexible input J, okay, markups are going to be equal to the output elasticity with respect to that input. Okay, so what I mean here is, imagine that input is labor, right? So as you change labor, how does your quantity of output change? Over the input expenditures as a share of revenue, right? So imagine this is your wage bill here over your total revenues. So what are the kind of pros and cons of this approach relative, especially to kind of the previous accounting measures?
There's a comment in the Q&A saying you have to estimate a production function by Nathan Gardner Hattesley.
Yeah, so you have to, that can be potentially a con, right? So you have to actually measure this output elasticity, which can be challenging. Absolutely. Any pros? So, the pro here in general is that you really only need decent records for one variable input, right? So in particular, the issue about valuing capital, which can be very challenging, we can basically set aside capital here and say, okay, instead, we're just going to focus on a different variable input. Labor is a very common one, right? And the idea here is it might be easier, this denominator here is really kind of the win for this approach, right? So it might be easier to estimate the wage bill, just this part here, rather than kind of the total cost and valuing capital, okay? So that might potentially be easier. Now, the downside, of course, and I should say actually just, quickly on that point, I think that's especially true in wealthier countries with good accounting data, at least on wage bills. That might still even be a challenge, right? Think about SMEs in low and middle income countries, right? If they have no employees or just a small number of employees, own labor is going to be a really big part of that wage bill. And we know sort of it's notoriously difficult to value own labor. So this is not going to be quite the win that it might be if the only issue is valuing capital. Okay, but that's the overall sort of benefit is the approach is you don't have to properly measure every input. You can just sort of measure the input expenditure for one. The downside is this point here about the output elasticity, right? So there's lots of identification challenges here. So I think you heard a lecture by Eric Verhoeven earlier in this series. He's got papers noting that basically if you don't account for quality differences, you might get biased estimates here. So, imagine that there's a firm that's using lots of inputs and they're not actually producing a larger quantity of outputs, but they're higher quality outputs, right? Then you're going to underestimate, if you don't adjust for quality, you're going to underestimate sort of this output elasticity. Here's an area where I actually think—
Clarification question. Do you think, would this exercise get easier or harder in the face of integer constraints? So if let's say my input is not actually smooth, that I can scale up and down, but actually I can only have one worker or two, I can only have one machine or two, but I can't really scale these up. I'm trying to build an intuition if this is making my life harder or easier here.
Yeah, I mean, I think there's two issues there. So one is just kind of like the mathematical issue of, are you actually getting sort of a derivative here? I think the other thing you mentioned is like, are there constraints overall? Are you really getting the production function, or are you getting some reflection of constraints here? So I think, I think that kind of all falls into kind of this issue around identification challenges. Absolutely. I mean, this is a place where I think development literature can do a little better, actually. So, we have, for example, interventions that have tried to increase, for example, like labor drops, right? I mean, we've seen interventions like that. We've seen capital drops. And so I think you can imagine kind of getting at this experimentally rather than looking kind of cross, within a firm and kind of thinking about those constraints. The other thing is just on the measurement side for quality measurement. So if you are, the downside is you don't have accounting data, but if you're going out and actually talking to firms and you could measure quality, you could potentially, try to actually, or measuring quantity, you can try to also measure quality as well. So I think there are ways to kind of try to deal with them. But as you said, there's lots of issues there, I think, that complicate this, this estimation. And the final thing is, of course, this is still descriptive, right? So again, I think very useful for if you're thinking about markups as an outcome of a policy shock. This is a very useful approach. It's not as useful if you want to think about, what happens if you increase the degree of competition, or, if you're trying to estimate the impact of policies that you're not observing in practice. Okay, and then sort of, the last kind of very large bucket of approaches that I'll talk about here is just kind of the full structural modeling. This is kind of the traditional IO approach, and I'm going to go over it in really high level detail, but you can think about, for those who are familiar, like the very classic BLP approach. And this approach, you basically assume a particular utility or demand function. You try to get supply shifters to estimate demand elasticity, and then you assume particular market structure and firm behavior, and those two things together imply particular markups or marginal costs. Now, of course, the benefit here is you know everything, so you can do lots of counterfactuals. The downside is there's lots of assumptions. So you're assuming, the shape of demand. You're even assuming market structure, right? So if the goal is to identify the market structure, this is not a fruitful approach. I will say, in fairness, not all these papers do this. So this very famous paper by Aviv Nivo on ready-to-eat cereals actually goes through this exercise for 3 possible market structures and then compares the kind of implied markups to actual accounting estimates, right? So you can, and that would be actually a somewhat similar approach to what we'll do in my paper with Michael Dinnerstein. So they don't all assume this, but a lot of them do. And then it's sort of circular for, not useful for identifying market structure. The final thing that I think is a little specific to development from this approach, but also maybe true a little bit in the general IO literature, but especially in development, is I think it's pretty hard to find good instruments to estimate this demand elasticity, right? And so in particular, in the developing country context, I work, for example, a lot in agricultural markets. So it's not so hard to think about, finding shifters of supply. So think, for example, about, weather shocks, shifting supply of production in different areas. But in a setting in which you've got very small markets and your producers are also your local consumers, of course, as there's weather shocks, you're changing household income, which is going to change demand in a bunch of ways. So actually identifying clean shocks, I think in these smaller markets where you have kind of this overlap between who's a producer and who's a consumer, can be quite challenging. That said, I also view this as a place really as an opportunity for development, right? So we do a lot, one of the things that development economists are good at, they're not exclusively, is running experiments. So I think there's actually lots of ways to think about experimentally estimating some of these key parameters that aren't going to then rely on these instruments or identification assumptions. Okay, so let's turn now to one example of that, which is work that I did with Michael Dinnerstein in Kenya. And it's basically an experimental approach to measuring the degree of competition in these markets. Let me give you a very kind of high level motivation behind this project and just a little bit the setting. So we're working in agricultural markets in Kenya. It's pretty common to see pretty large variation in prices across these markets, and it suggests these markets are sort of imperfectly integrated. And this is a big interest to policymakers. They're concerned kind of on 2 fronts. One is that, there seem to be low prices for farmers, crops are their main source of income, and the flip side, kind of high prices for consumers, and that raises issues of food insecurity. So there's a question is kind of, where is this gap coming from? Of course, just high transaction costs play a large role. So there's high transport costs, search costs, risk, et cetera. But many policymakers are concerned that part of that gap in prices between, say, farm gate price and consumer price is markups by intermediaries, so traders who are buying from farmers and selling to consumers. And the idea here in this context is this is a context where there are not large barriers, legal barriers to entry, at least not ones that are enforced, but there are large de facto barriers. So you have to have a good deal of working capital, also a network of contacts to enter into the industry. And the idea is these barriers might allow these intermediaries who are then, the few who are able to overcome these barriers might be able to exert market power and potentially even collude. So that's the backstory. So in this paper, we're going to provide experimental and model-based evidence on 3 questions. So first, what is the market structure and level of competition among traders? 2, how does this market structure affect consumers? And 3, what role does entry have in facilitating competition? So I want to give you I'll tell you more detail about the experiments in a bit, but before I get into the theory, I want to give you a very high level of understanding of the experiments because they map to the theory pretty closely. So we work in 60 markets in Kenya. We run 3 field experiments, and each of these experiments estimates a key parameter or moment in a model of competition, demand, and market entry. Okay, so the first experiment, again, I'll give you more details in a moment. The first experiment is designed to estimate pass-through. So in this experiment, we offer to all traders who are located in randomly selected markets, we offer them a subsidy per bag of maize that they sell to consumers. And we model this like a reduction in their marginal cost. And we measure how much that reduction in marginal cost they pass through to consumers in the form of lower prices. So we're going to get experimental estimates of pass through. In the second experiment, we estimate demand. So we offer randomized reductions in the price to consumers, and we measure the corresponding quantities they buy at those randomly reduced prices, and that's going to allow us to estimate demand. And in particular, I'll show you in a moment from the theory that the curvature of demand is going to be the really key feature here. These 2 things together are going to tell us a lot about the underlying model of competition that these traders are operating under. And then the third experiment measures the impact of entry and competition. So in this experiment, we randomly offer an entry subsidy to bring new traders into the market. And we measure what happens to prices and what happens therefore to competition when new entrants come in. We're going to then take these experimentally estimated parameters and embed them in a structural model, and that's going to help us to identify the level of competition and the effects of entry. Okay, so a little more detail here. So we're working here in Western Kenya in these 60 markets you can see here around this area called Bungoma and Kakamega. The way these markets work, they're sort of open air weekly markets. So for example, you might have your local market, might be a Thursday market. So every Thursday there's a market. Traders show up bringing maize to these markets. They'll bring them in these trucks and they'll sell out of the back of their trucks. This is sort of the most common thing you'll see where the modal market has 3 traders and they'll sell basically to consumers who line up right here out of the back of their truck. I think I'll skip most of this. Let me say, I think the basic thing to take away here is this is, pretty much a spot market of pretty homogeneous goods. So there's very little sold on credits. There's not much evidence of price discrimination or product differentiation or price stickiness. So you might think this is actually a pretty competitive market. On the other hand, you can see these guys are sitting right next to each other. It's not so hard for them to observe each other's prices and talk. Okay, so let me now give you sort of the simplified theoretical framework that underlies our experimental approach. I should say, in what I'm going to show you here, I'm going to make a couple simplifying assumptions. For example, I'm going to assume constant marginal cost, symmetry across traders. There's a full structural model in the paper that relaxes all those assumptions. Doesn't make a big difference for the results. We still identify all of our estimates experimentally when we relax those assumptions, but I like this simplified approach to show first because it really has a kind of clear mapping one-to-one between the parameters we're estimating in each experiment and the theory. Let me kind of walk you through this kind of simplified framework. So trader J is going to choose quantities, right, to maximize first his profits, right? So it's just price minus cost times his quantity, right? Again, very simple. plus the weighted sum, and we'll come back to these weights in a moment, of the profits of all of his rivals. Okay. And so how do we interpret this profit weight here, this omega? So this is going to basically embed two well-defined models of competition. Okay? So when this is zero, right, when omega is zero, this whole term goes away, and we're just back to Cournot competition. Conversely, in the other extreme, when omega is one, right, that's as if the trader is putting equal weight on his own profits and his rivals' profits. So they're basically maximizing as if they're a single firm. That's perfect collusion. And there's ways to even embed kind of Bertrand competition in here as well. So we can take the first derivative with respect to quantity to get the optimal condition for price. So price is just going to equal cost plus some markup term here. Right? And this markup term is going to depend, of course, on the shape of demand, which we'll estimate and come back to in a moment. But it's also going to depend on two features that are determining competition. Okay, first is N, the number of traders in the market. And then second is this omega term, right? How do those traders interact? So we're going to summarize those two features of competition, the number of traders in the market and the way those traders interact, into a single competitiveness index parameter. Okay? And this is going to be useful in just a moment. And again, we can think about what this is when we're in a Cournot competitive environment or a collusive environment. Okay? And again, also Ness Bertrand. Okay, so I'll come back to why we've kind of gone through the algebra here on sigma in just a moment. Let's go back to the first order condition here. Again, remember price is equal cost plus a markup term here. So we can take the derivative with respect to cost, okay? And that's going to get an equation for pass-through. So what is pass-through? Pass-through is how do prices change when costs change? Okay? And what you can show is this pass is going to be a function basically of two features of the market. The first is that competitiveness parameter, okay? The sigma. And the second is this E term. Again, this E term is reflective of demand. And specifically, E is equal to the elasticity of the slope of inverse demand. Okay? So that's more complicated than just the elasticity of demand. This is the elasticity of the slope. How is the slope changing with quantity? Okay? And I'll give you some graphical intuition on that in just a bit, but you want to think of basically the curvature of demand being particularly important here. Okay? So again, the takeaway here is that pass-through is reflective of the degree of competition in the market and demand. So let me now map that to the experiments we're going to run in this paper. Okay. So we're going to estimate rho or pass-through from the pass-through experiment. We're going to estimate E, this term on demand, from the demand experiment. And those two things together are going to allow us to back out the implied competitiveness parameter, right? So when we combine these two features of the data, we're going to be able to say, you know, this is the underlying sort of model of competition that best fits what we're observing in the marketplace. Let me pause there and ask if there are questions.
Lauren, there's one from the chat. How confident do you feel about the market boundaries? Is there arbitrage going on between subsidized and unsubsidized markets? Although you may want to answer that in a few minutes.
Yeah, no, it's a great question. So we and that matters, I should say, for measurement in a couple ways, right? So for example, if our control markets are too close to our treated markets, then we might be changing prices in control markets, right? And then we're not going to get the right estimate of pass-through. So there's a really basic sort of measurement issue here. So we intentionally spread out our markets quite a bit. So we did a census of markets and then basically kind of drew parameters or, you know, or radii around each of the markets in our sample. And so we intentionally spread them out and we could, you know, test for what happens to having a market sort of somewhat nearby that's treated. It doesn't affect your quantities. So we don't think there's an effect on our control group. I will say it does seem like there might be some slight sort of business stealing from other closer markets that are not in our sample. And we have sort of an appendix sort of looking at that. So I think this is, and that's real, I should say, that's real additional business for the traders. So I think it's sort of okay to include in our estimates here. But that is a slightly nuanced point. And I think it's really critical when you think about in general doing market level experimentation to think critically about these boundaries in terms of how they affect, one, your measurement of the treatment effect, and then two, kind of your interpretation of what that means. I'm happy to come back to that sort of once we go through the experiment or even at the very end when I discuss sort of at the end of this lecture, I'll discuss more broadly kind of market level experiments. That's a great question. Other questions?
There's one more quick one, which is you mentioned that it's often common that people are both producers and consumers. How do you deal with those issues? For example, pass-through may be different for firms where the producer is also a consumer.
Yeah, that's a good point. So in this context, because we're working with large traders, they are possibly consumers. They're not going to be in our demand experiment. There's a very small number of them. I worry about that much more when you think about, for example, working with individual farming households as being kind of the firm. In this case, the firm here is going to be the trader, and so they're going to be kind of a drop in the bucket in terms of demand. And for the panelists, I should say it might help if you have questions. If you click the raise your hand button, I think you will then rise to the top of my screen, which could be helpful. So I don't want to ignore any of you. Okay, so in experiment 1, let me tell you more details about each of the experiments. So in experiment 1, where we're targeting this pass-through parameter. So how did this work? So we randomly selected markets, and in those randomly selected markets, we offered to all traders in the market a subsidy per bag sold. Okay? And the goal here, again, is to sort of mimic a common shock to their marginal cost. So we offered to all traders in a given market the same subsidy level, but there was randomized variation across markets. So in 3/4 of the markets, we offered a low subsidy. Now, low is just relative to high. It's still pretty large in absolute value. So it's 8% of total price. And in 1/4 of the market, we offered a high subsidy of 15% of total price. The reason we had this variation will become clear in a moment. We're going to use this to test a particular functional form we're going to place on demand. The subsidy is offered for 4 weekly market days in a row. So if you're a Thursday market, it's offered for 4 Thursdays in a row, covering a month in total. This is actually a big chunk of the selling season. The really active selling season is about 3 or 4 months. So this is about a third or a quarter of the selling season. And then I won't have time to describe this much in detail, but we have really detailed transaction level data. We had enumerators who are sitting there monitoring sort of each transaction. And that's going to allow us to estimate how much of the subsidy is passed through to consumers. Yeah, is there a question?
Yeah, what's the rationale for not varying within the same market over time, these rates? Wouldn't you get interesting variation there?
Yeah, I should say actually, so that is what we do actually. So I'm not sure I'm being full, but essentially, basically, markets are kind of rotating month by month through the different treatment statuses. So we are able to basically include kind of market fixed effects by seeing what happens when a particular market's in control. Yeah, and that's actually pretty critical. That reduces our standard errors quite a bit. It also allows us to see kind of if there's kind of any stickiness, does it affect prices in the next period? And the answer is no. So that's useful in a couple of ways. Yeah, good question. The second experiment is the demand experiment. Okay, so here we offered randomized discounts in the prices that are paid by individual consumers in the market. So here's how it works. So consumers would agree to a price and quantity with a trader. Then after that, we would have them draw one of 10 randomized discounts. We then allowed customers to choose the quantity they wanted to purchase at that reduction in price. And what that's going to give us basically is an exogenous shift in price and the resulting change in quantities. And that's going to allow us to parameterize a pretty flexible functional form for demand and estimate that curvature term, that E term. And I'll give you more details on that exact estimation in a bit. The third experiment is estimating the effect of entry. So for each market that was randomly selected for entry, we identify 3 sort of entry traders. These are potential entrants, folks who have never worked in that market before. And we offer a grant to enter the market on particular days and attempt to sell. Now, we offered these 3 grants partially just to make sure we got sort of a strong first stage for entry. The benefit of these 3 different entry offers is we're able to randomize the size of those grants into low, medium, high. That's basically like variation in subsidizing their fixed cost to entry, right? It's a fixed grant. And that's going to allow us also to back out fixed costs, which is going to be quite important for once we get variable profits, understanding sort of what total profits look like. Again, these offers are given for 4 weeks in a row. The goal is here to induce sort of long-ish run entry. And then we collect transaction level data to measure the effect of increasing the number of traders on prices. And we can back out then the model, what happens to the underlying model of competition when entry happens. Questions there on the design? Yes.
I was wondering, can you say anything about how this sort of encouraged or incentivized entry different from the entry of in a sort of like a natural condition where they just like do it themselves instead of it being incentivized to do that? Like,
Yeah.
how different is it gonna be?
Yeah, so I think you might worry that this is sort of artificial. Is this kind of like, natural entry? And so we can't say for sure. I mean, I will say we tried to do it for kind of long run. There were actual profits on the table for these folks. They actually went in there and actually sold. So I think people took it pretty seriously. There is a question of, is this what you would see sort of in reality with natural entry? And the way we can sort of answer that, we can't answer that for sure. That's an external validity question. What I can tell you is, given variation in what we do see, how would you then apply that to kind of natural entry? So for example, just to preview something I'll share in a moment, we found that it was easier to get entrants. So no one had worked there before, but it was easier to get entrants in who knew the incumbent. So a lot of these guys kind of know each other. So some people kind of knew some of the incumbents, some people didn't. We basically, for lower values of that entry grant, people were more willing to go if they knew the incumbents. And so you might think that's then meaning that in reality, if you weren't subsidizing, the entrants are more likely to kind of know the incumbents. Then the second question you should ask is, how does that then change the effects of entry, right? And we find basically, and I'm totally spoiling the ending here, but what we find basically is that entrants by entry by entrants who know the incumbents doesn't increase competition at all. So it's going to look collusive before, it's going to look collusive after. Entry by new traders who don't know the incumbents does actually seem to do a little bit for increasing the degree of competition. We do see more price drops with those that level entry, but those are the guys who are hard to get in. So if you think about kind of the marginal entrant in reality, it's not going to be the totally new guys, right? And so that's sort of what we can say given the variation that we see in the data. Yeah, Timothy.
Just a very operational question about like managing this in the field of the enumerators can see all of the, like they're standing in one place and can see all of the trades happening at once. How much can the traders see of each other? How do you hire the right number of people to make sure that you're observing enough that you're actually?
Yeah. This was like a whole, the whole field operation. So we had a variable number of enumerators. So there are many more than one. There's sometimes one-to-one mapping of enumerators to traders. It really depended on the overall sort of intensity of trade sort of in that part of the season. So for a very intense part of the season, we had a one-to-one mapping of an enumerator to a trader. And less intense ones where there were fewer transactions, we had one enumerator maybe for every 2 traders. They can go back and forth, but they're literally observing every transaction. So it was I'll say this is not a cheap experiment, and it was very labor intensive.
And the traders in all of these markets can always see what the other traders are doing?
Yeah, because and there is some variability in this, but if you look back to kind of the layout, so can these guys see what the others are doing? Maybe not, but they're generally very clustered in the marketplace. Now, there's reasons for that totally besides collusion, which is like this reduces search costs for consumers, right? To know you kind of go to this part of the market and you see. So I think this is not like prima facie evidence of collusion, but yes, they're very close together and they're kind of sitting there chit-chatting out of the back of their trucks. I will say we do in that measurement of transaction cost, we try to also, of prices, we also measure, are there sort of less obvious changes to prices? Like, for example, there are these little things called top-ups, which means you might give a few extra kgs of maize that were not included in the price. You might even give a Coke or money for a motorcycle taxi to take. And those things, when we include them, that actually does increase the degree of pass-through observed by about 1 to 2%. So that might be a slight way that there's kind of, those are less observable ways of cutting the price, but it's pretty limited. Other questions? Okay, so let me show you. I've previewed already the results a little bit. So we basically see very limited pass-through. So we're able to estimate a pretty precise 22.4% pass-through rate. That doesn't change by, first of all, the low-high distinction. Okay, so it's almost an identical pass-through rate. Even when you double the size of the shock, and we'll come back to that in a moment. There's also no obvious heterogeneity by, for example, it's not the case that in larger markets you see greater pass-through than smaller. That's already some evidence against Cournot competition, but we'll come back to that in a moment. Okay? So overall, kind of 22% pass-through rate. Now you want to ask, how do we interpret that pass-through rate? What underlying model of competition has given rise to this empirically observed 22% pass-through rate? And I want to give you like very simple Econ 1 graphical intuition on why we don't know unless we understand what demand looks like, right? And so what I want to point out here is you could have just as equally been in a collusive environment or a Cournot competitive environment that gave rise to that 22% pass-through rate. So why is that? So we basically induced this experimental reduction in marginal cost. We've seen, you know, this reduction in price. The ratio here is kind of roughly, imagine it's 22%. This could have come from this model of collusive behavior, but it could have also just as easily be observational equivalent of a Cournot competitive environment with this shape demand. Okay, so the really critical thing to know, are we in this world or this world, is understanding the curvature of demand. Okay, so that's why we have to go to the second experiment to estimate demand, to back out from this pass-through rate, what is the underlying model of competition. So that's the demand experiment. So this is just showing you kind of the raw data from the demand experiment. So we offered these randomized reductions in price. We measured the corresponding change in quantities. Okay. So, you know, downward sloping demand, that's a good first start. Okay, so this is the raw data. We're then basically going to use this experimental variation in price to estimate a general sort of Bulow-Flighter class of demand functions. Now, this may look a little bit funky or unusual, but I want to just highlight a couple of things. You know, the first is that this actually nests a bunch of demand functions that are probably much more familiar to you. So this is going to nest linear, quadratic, isoelastic. The reason we're using this particular class of demand functions is because the kind of defining feature of this class of demand functions is it's going to capture curvature with a very small number of parameters. Okay, the curvature we really care about, and here under this class of demand functions, this delta here is going to be the really critical piece. Okay, so here that very complicated E term is going to simplify to delta minus 1. Okay, so it's going to be pretty parsimonious and much more tractable. Now you might say, okay, it's parsimonious and tractable, but is it totally crazy? Does it actually fit the setting? And that's where those two different size subsidies come into play, right? So one prediction out of this class of demand functions is that for, you know, a given market structure, which it was randomized, the market structure should be the same in low, high subsidies, you should see a constant pass-through rate. Okay, and that's what we find. So I think there's some empirical support as well for this. So, you know, we're going to take log first differences, the previous equation, and estimate this using GMM. The really key thing here is we're using the randomized subsidy amounts as an instrument for price. So these are the results. Delta here, as I mentioned, is kind of the key term. So our estimate of delta is around 4. I want to highlight something very transparently, which is we're getting really large confidence intervals here in delta. Okay, and that should not be a big surprise to you. Delta is the second order sort of curvature term. Okay. So, you know, we can just barely rule out kind of linear demand, which would be a delta of 1. We also cannot rule out, you know, a very curved delta of very curved demand of a delta of 6. Okay. So we're not getting a ton of precision on this really critical term. But what I'm going to show you in the next couple of slides is that first, if you take delta at its point estimate, okay, the right model of competition is going to sort of jump out at you. It's going to be very obvious kind of what fits with this particular estimate. The other thing I'm going to show you, the second thing, is that even if you take into account all the uncertainty in delta, we still have enough precision to rule out some of the other common models of competition. So let me show that to you now. So remember, sort of for the simplest model, price can be a function of that competitiveness parameter and demand. Okay, and now here, because we have this particular functional form, that E term is basically just simplifying to delta. Okay, so let's put all the kind of pieces together. So now we've estimated delta from the demand experiment. Okay. We have, you know, benchmarks for sigma under various market structures, right? We can test collusive, Cournot competitive, or sort of Bertrand competition. And so we can say, putting these two pieces together, you know, what pass-through rate, what row here should we have expected if markets are operating under each of these market structures? So let me show that benchmark to you here. So our predictions, given our estimate of demand curvature, is that if markets are Bertrand, right, we should see 100% pass-through. If they're acting Cournot competitive, given kind of distribution of the number of traders, we should see on average a 46% pass-through. Okay. And if they're collusive, we should see almost a 20% pass-through. Right. Okay. So those are the benchmarks. We want to now compare this to empirically what we actually observe as the pass-through rate. Okay. And so here's what we found. So you already saw, we have a 22% pass-through rate, and this is the bootstrapped confidence interval, 95% confidence interval around the estimate, right? So we can rule out here Cournot competitive and Bertrand. Okay? So it's very clear, sort of given at least the point estimate and delta, what the right model is. Okay? Now you should say, well, yes, but there's that huge confidence interval around delta. Are we really confident, right? And so what we can do is basically just rearrange those terms, right? We're just going to solve here for sigma. And now we can take into account all the variation in delta, all the variation in rho, right? Taking the bootstrap distribution of both of those, right? And get the point estimate and distribution on sigma. I'm going to slightly adjust this to solve it sort of as the profit weight. I think that's a little bit cleaner mapping back to the theory. So remember, 1 is collusive and 0 Cournot competitive. Okay, that's the weight that you're putting on your rival's profits. Okay. And we see as our point estimate, right, is an omega of 0.78. So almost an estimate of 1, basically. And even given all that variation, right, even given our imprecision and our estimate of delta, we can still rule out with 95% confidence an omega estimate that's consistent with Cournot. Okay. So we say is given the point estimate, it looks really close to exactly what you expect, given collusive collusion, and we can rule out Cournot competition. We do a bunch of other stuff in the paper. So I mentioned we kind of move beyond that simple model. We account for potential non-constant marginal cost, again, using additional experimental variation. We bring in trader heterogeneity, demand heterogeneity. It doesn't change much. So our estimate of omega, given all that, is 1.07. Okay, but very, again, still very much centered around that kind of 1. That's the collusive benchmark. I won't have time today to discuss kind of the full entry results, but I've already previewed them for you, right? So first, the take up of that subsidy amount is going to allow us to estimate the distribution of fixed cost. Then we see what is the impact of entrance, okay? And we find basically the entry by 1 additional trader is reducing prices by about 1%. So it's significant, it's pretty precisely estimated, but it's a pretty small reduction in prices. We see this heterogeneity by this feature I mentioned before. Do traders have contacts in the market? Okay, so when they already have contacts in the market, you can see it's really not changing omega much, right? Going from 1.07 to 0.95. So you can reject Cournot competition, and you clearly cannot reject kind of collusion at 1. On the other hand, entry by completely new traders who don't have any contacts with incumbents or don't know the incumbents at all actually does seem to decrease competition. So here we actually can rule out collusive behavior, okay? And we can't rule out Cournot. So it does look like this entry by new traders does seem to increase the degree of competition. But if we go back to kind of those take up results, right, who's most likely to take up, we find it's harder to get traders without contacts to enter. You literally need to pay them more to get them to go. It suggests, right, that having contacts sort of facilitates your willingness to enter. Okay, so, given all the structure, we can do a lot to kind of quantify what do markups look like, what do variable profits look like. I'll say, markups are pretty large. They're kind of in the 40 to 50% range, but fixed costs are also pretty large. And so that's going to dissipate 71% of the variable profits. Okay, so actually for the median trader, they're not making huge profits in this context. However, there's lots of variability across traders. Okay, so the largest traders who are serving the largest part of the market, they are making really large profits. And so, the take home here is that even though the median trader is not making huge profits, the typical consumer is being served by a trader who is. So when you think about kind of total surplus in the market, traders are capturing, over 80% of the surplus in the market. And then finally, we can do, counterfactuals again, because we've estimated sort of all the things we need to describe the market. We can estimate counterfactuals. What happens if we go from kind of this collusive benchmark, which what we estimate is sort of the right model of the current degree of competition. And what if we're able to kind of lower that omega down to Cournot competitive, right? To increase the degree of competition going to the left. And so as you expect, consumer surplus kind of goes way up. That's partially at the cost of trader surplus going down, but it's also partially coming from a reduction in deadweight loss, right? As you're decreasing sort of the market power in this environment. Let me actually pause there and ask their questions on that paper. Yeah, please.
So I was wondering if you could say, this probably goes beyond the scope of the study, but I was wondering if you could say something about the structure of the market, like in a sense that, because I feel like this is the results shows that there is a stable sort of collusion going on. So what is supporting this? What's the mechanism behind this joint profit maximizing? And we also see there are like some giants basically working there, earning most of the profit? Is it because they're so some of them they are colluding with each other, and then other followers they benchmark their price based on those, like the market leaders, something?
Yeah, it's a good question. I don't have much to say about the last point, although it's a really interesting question as to kind of how the exact price setting agreements happen. So that I don't know. In terms of kind of what's maintaining it, I actually think the physical layout of the market becomes really important here. So you can imagine kind of the period of benefits from defection might be quite low if you're kind of immediately detected. And then right away, sort of the collusive agreement breaks down. So you can imagine this in an environment where sort of, immediate detection basically of kind of that breakdown in the price agreement could lead to kind of a real loss in profits. So I think that's sort of the ability to kind of maintain. I should say, I'm not convinced that it's always even like an explicit agreement, though you saw actually a large percentage of traders do sort of, a large percentage of markets have at least one trader who's admitted there is an explicit agreement. But even sort of, it could be potentially, tacit, but they're sitting there kind of watching each other as well. Yeah. Other questions?
Are there hierarchies between the traders? Could there be something like there's kind of the big guy who's always been there, who's goes first and sets, and the other ones just watch and see what they do?
Right. Yeah, I think it's kind of a size question. I don't really know the answer to that. It's a great question. Like, is there kind of a leader who's setting the price and then others kind of follow? So I don't know. That's a good question. Yeah. And that might be relevant for thinking about kind of how do you, if you wanted to target policy to potentially break some of this down, sort of who would you target? Yeah, absolutely. Okay, so in our last half an hour, let's turn to sort of, we talked about kind of measuring competition. Let's turn now to kind of implications of competition on market outcomes, right? So we'll talk first about impacts on firm selection, sort of who survives, who exits when competition's increased. And then I'll talk just very briefly about sort of 3 other really nice papers looking at the impacts on prices, quality, and contracting. Okay, so we'll start with this Jensen and Miller piece. So the overall kind of motivating question behind this paper, which is, a really huge one in this space, is why do good firms in this context, why do good firms, whether low cost, high productivity, high quality, why do those good firms fail to grow? And the flip side of that coin is, why do these bad firms fail to exit, right? Why do they remain in the market? So one possible explanation is basically a lack of competition. And in this context, they're going to look at a lack of competition due to market isolation, okay, or limited integration. So we kind of raised this point before. How do you define this? This paper is essentially changing the boundaries of the market. Okay, so what are these barriers to market integration? Lots of barriers that are possible: high transport costs, tariffs, et cetera. Here, this paper in particular is going to focus on information frictions or search costs. And the idea behind these information frictions is that it's difficult for consumers to learn about either the existence of firms in different markets and other markets than their own local market, or you might know about the existence of the firms, but you might not have a good kind of credible signal on their quality. You might not know the quality of those firms, right? So in some way, you have better information about kind of your very local firms, and you know less about firms that are further away. That's going to limit kind of the size of the market, and therefore how much firms across markets are competing. So, as a result of these information frictions, consumers are going to often buy almost exclusively from their local producer. Conversely, right, producers are going to sell mostly local consumers, and that's going to have 2 effects. The first is it's going to limit the consumer base that can, and that can inhibit good firms from growing. Okay, so the first is kind of a tax, a negative impact on good firms, right? So they can't expand to other markets. That means they can't grow, they can't exploit economies at scale. That's going to limit kind of the first part. Why do good firms, fail to grow? The second point is that it's going to have limited competition from across markets, right? So the bad firms are not going to be competed out of the market, right? They're going to instead survive, and that might lead to kind of lower aggregate productivity in the entire area, and also lead to kind of cross market or cross firm productivity dispersion. Okay, so this Jensen and Miller piece basically says, when a technology comes in that facilitates search, right, that essentially reduces some of these information frictions, do we see better market integration? And does that increased market integration basically lead to competition disciplining the market, right? So do we see a reallocation of profits and market shares towards the good firms and away from the bad? Okay? And this is sort of, a micro empirical example of a very classic sort of, Mellett's model of the pro-competitive effects of, trade or increased market integration. So this paper is going to use the same shock that a previous paper of Rob's uses, which is the rollout of cell phones across markets in India. So let me just give you 2 slides on kind of that initial paper, just so you can see kind of the baseline setup. So this is looking at the state of Kerala in India, along the coastline, and one of the big industries in this area is fishing, right? And so this first paper, the 2007 paper, is using the rollout of cell phone towers along the shoreline in the state of Kerala as a shock to basically information friction. So what's happening in that first paper is he's studying fishermen. Fishermen tend to kind of go out into, to hunt for fish that day. They come back, and at baseline without cell phones, they tend to just sell to their local market. Now, some fishermen are kind of lucky and have good catches that day, some have bad. And so what happens at baseline is some of these local markets have very high supply, some have very low, and you see lots of variability in prices across markets. Once these cell phone towers roll out, it becomes much easier once you're out here to say, well, maybe I won't go to my home market that day. I'll go to the next one over if they've got low supply that day. So the reduction of this sort of information cost through cell phones allows fishermen to better arbitrage. They end up going to different markets, and you see much smoother supply. As a result, you see much smoother prices across markets. So this is like one of my favorite all-time graphs of all time. We should all be so lucky to find this sort of result. So this is showing you basically what happens when the introduction of cell phone comes in. So you see really clearly, right? So region 1, prior to cell phones, tons of price variability. Cell phones come in, boom, law of one price, basically. Same thing for region 2, lots of variability. Cell phones come in, boom, law of one price. Same thing for region 3. Okay, so just super clear in the figures what's going on here. A really big change and reduction in price dispersion. Okay, that's kind of the backdrop for this paper. That was the first paper. This paper is gonna turn things around a little bit and think about now the fishermen as consumers. Okay? And what are they consuming? They're consuming boats. So this paper is going to look at the introduction of cell phones and say, what was the effect on boat builder quality and firm selection? Okay. So let me tell you what's happening at baseline, and then we'll talk about what happens when cell phones come in. So at baseline, these fishermen are buying boats almost exclusively from their local producer. Okay, 97% are buying from the boat builder in their home village. And there's roughly one boat builder per village. So along the shoreline, you see, each village has their own boat builder, and all the fishermen from that village are buying from their local boat builder. Okay. Now, some of those boat builders are really good and some are not so good. And so there's lots of variation in quality across the boat builders. And they do a really fantastic job of doing 4 different measures of the quality, et cetera. Okay. They've got independent auditors, they've got self-reported, et cetera. But no matter how you cut it, lots of variability in quality. Okay. Now, what happens now? They're going to use a slightly different cell phone rollout. So I want to just be clear about that. So they're going to use these, again, 3 regions. Region 1 is going to get cell phones in 1999. Region 2 is going to get it in 2000. Okay. And region 3 doesn't have cell phones for the entirety of their study period. So region 3 is like a pure control. Okay, so what do they predict is going to happen, right? Kind of a la this Mellett's model. So the idea here, the causal chain, and I'm telling you this now because the graphs are going to really closely kind of mirror each of these steps in terms of the results. So first, cell phones will cause fishermen to travel to different markets to sell their fish. Okay, that was already shown in the first Jensen piece, but we'll see it replicated here. Okay, so fishermen are going to new markets to sell their fish. In doing so, they're interacting with other fishermen, right? And they're chatting about, for example, where did you buy your boat? How good quality is that boat builder? They're getting information about non-local boat builders. So they'll learn about, again, first the existence of non-local builders they didn't know about before, but they'll also potentially form a more accurate signal about the quality, right? So there's some natural variability in, say, the quality of the boats. The main measure they'll have is kind of the longevity or how long the boats last. There's some natural variability there. You might need multiple sort of people's assessments to get an accurate signal of the quality. Okay, so they can source multiple estimates from lots of non-local fishermen and get a more accurate sense of the quality of these non-local builders. Okay. Once they kind of know who the best builders are, including non-local builders, fishermen are going to start buying boats non-locally, and this will lead to greater competition among the boat builders. Okay, this is kind of the anticipated effect. As there's more competition, what should happen is that you should see the good builders expand, okay, and the bad builders contract or exit. And then finally, this might improve aggregate productivity in the industry, and perhaps might lead to improved outcomes for consumers. Okay? So this is kind of the predicted causal chain. Let's now see sort of what actually happens in practice. And I'm going to actually just show you the graphs here because I think they really sort of speak for themselves. So how do you, let me just tell you sort of how you follow these figures, since we're going to see a couple of these. So each column here is a different result. So this is looking at, for example, the percent of farmers who sell fish in their own village. This top row is showing you for region 1, which got cell phones here, this blue line in 1999. Region 2 got cell phones here in 2000, and region 3 is a pure control. They didn't get cell phones during this entire period. So let me actually talk about first what happens in region 3, which is basically the control group, right? So you see basically 100% of fishermen are buying or selling fish in their own village, okay? When cell phones come in, what happens? So fishermen start selling fish, outside their home village, right? Similarly in region 2, again, kind of no pre-trend, but right when cell phones come in, they start selling fish outside their own village. So they are going to new villages to sell their fish. The idea here is they then start talking to each other and getting a more accurate signal on the quality of the boat builders. Okay? So panel B is looking at that error in estimating the quality of boats, in particular, the boat lifespan in years. Okay? So they have kind of these objective measures of boat quality. They also ask fishermen to estimate, and they take the difference as kind of the absolute value of the difference as the error. So again, let's go to region 3 first, which is basically the control. We see on average, right, the estimates for the non-local builders, the errors are much higher. So people have worse information about non-local builders than they do kind of their local guy. And again, that kind of persists throughout this entire time period in the control group. You see a similar thing in region 1, but what happens when cell phones go in? Well, it looks like sort of slowly over time, fishermen start getting better information about the non-local builder. And sort of by the end of the period, it basically converges. So they're sort of equally well informed. The error rate is the same between non-local and local builders. You see a very similar thing in region 2, right? Again, no pre-trend, but then as soon as cell phones come in, again, sort of this convergence of knowledge. Okay, so now fishermen are better informed about the quality. What does that do to where they buy their boats? Okay. So again, basically 100% in the control group are always buying locally, buying in their own village. What happens when cell phones come in? This drops and drops pretty rapidly, right? So you go from basically 100% buying in their local village to, about 20 to 30%. Same thing here for the introduction of cell phones in region 2. So this is kind of the first part of the causal chain. You're seeing basically getting better information and buying non-locally. Now, what happens to firm selection? So here we're looking at the total number of firms. So a reduction in the number of firms implies firm exit. Okay. And you see, in region 2, there's basically a pretty steady number of firms up until mobile phones are introduced. And then you see a pretty rapid decline in the number of firms. So, this is like almost a 60% decline. Same thing for region 2, basically sort of a steady number of firms up until cell phones are introduced, and then a lot of firms exit when cell phones come in, okay? And no change in region 3. Now, the particular prediction is that this is going to basically lead to greater exits among the low quality firms, right, as they get competed out by the high quality. So they can break this up into above, below, median quality as measured by these baseline lifespan of the years of the boat. And what you see is there's some declines among both, but they're really concentrated in the below median quality firms. Okay, so it's really kind of these below median quality firms who are seeing the greatest exit. That's kind of the first step of the causal chain. You introduce cell phones, fishermen start talking, they get better information, they start buying non-locally, and as they do, this is going to lead to the exit, especially by the lower quality firms. They also asked, do we see any aggregate productivity gains, right, as a result of this reallocation? So they're going to here look at aggregate production. This is production by all firms aggregated at the regional level. They'll look first to see are there changes in the number of boats sold. They don't find any differences there. So overall quantity of boats sold isn't changing, but the lifespan of these boats is changing. Okay, so if you look at baseline versus end line in region 1, you see kind of this rightward shift, sort of all along the distribution, improvements in the years of the boats. Okay? Same for region 2, these big increases, not much of a difference in region 3 where there's no cell phones. They do a bunch of other pretty clever things to kind of isolate the exact causal mechanism, what's going on here that I really like, and I'll just mention them briefly. So, you could ask, is this increase in average quality, is that coming from a reallocation of to firms with higher baseline quality? And sort of the story I've been telling so far. You can also imagine that firms internally are upgrading their quality in response to competition. They estimate this super simply by basically throwing firm fixed effects into the regression. That kind of isolates the part that's within firm quality upgrading in response to cell phones, and they find basically nothing there. So their takeaway here is this is mostly happening from reallocation to kind of baseline higher quality firms, rather than firms kind of upgrading their quality within their firm. They also find a reduction in cost, okay, especially labor cost in particular. And they can ask a similar question, is this due to a reallocation to firms with lower cost at baseline, or due to kind of reductions in cost within firms? Again, they use those firm fixed effects, and here they see kind of 50-50. So this is partially reallocation to lower cost firms, so more productive firms at baseline. It's also due to a reduction in cost in firms. And this reduction in cost is coming from a pretty interesting place. They find basically evidence of economies of scale. So basically, as these firms are getting, the existing firms are getting larger, right? The ones who stay in business are getting larger, they're able to have workers specialize. Okay? So rather than having a single employee do all the parts of the boat building, they can have 2 employees, one who does the first part, one does the second, and they specialize. So they see a fall in task per workers. And that suggests there's some economies of scale here. The final thing is looking at consumers. So what happens to sort of prices and quality overall in the market? So they do see a slight increase in the price of boats, about a 4% increase, but they see a much bigger increase in the average quality in terms of the boat lifespan. Okay, so they can basically do sort of a price adjusted by the quality, so a price per boat year of life. And this falls quite a bit. Now they note this is sort of the short-term results, but it does look like sort of overall consumers are getting sort of higher quality at lower prices per kind of year of the boat. Okay. So this is sort of, I mean, this is a really, I think, nice paper because it's super reduced form, but it's basically kind of showing you all those causal steps of, you see a reduction in some of these frictions that might be inhibiting competition, right? Meaning you're kind of in these very sort of individual fiefdoms of these markets. You reduce these frictions, you increase competition across markets between these firms, and you see kind of the classic force you'd expect. You see basically the bad firms are exiting, the good firms are growing, and they're able to specialize and take advantage of economies of scale. Let me pause here before going to the next set of papers. Are there questions on this paper? Okay, so we only got another, oh, please, yeah.
Well, I mean, sorry, there is a question from the Q&A that I think relates to several of the papers you're talking about. So it's from Hermes. How do you see the role of intermediaries in competition, and how may it alter the implications of competition that you're talking about, I guess, in general so far?
Yeah, so I should say that in the Jensen piece, they go through a lot of work to kind of describe how like there aren't intermediaries in their context. I mean, I guess I think of the kind of link between these two papers, you want to intermediaries is, if there were intermediaries between these markets, you might imagine that, one of the frictions that Jensen is thinking about reducing is search costs, but you can imagine another friction is, in a more general sense, not in this particular context, but could be intermediary markups. And so if you're able to reduce intermediary markups, right, that is another way of basically integrating the markets more directly. So it'd be interesting to see, again, I don't think that the equivalent producers in the intermediary, equivalent of the Kenya agricultural stuff is farmers. And I suspect farmers don't have a lot of market power, but imagine you had intermediaries in a market where the original producers had market power. You might find if there a way to kind of reduce markups among intermediaries that would be like better kind of integrating these markets, you might also find kind of upstream effects of increased competition among the upstream firms. So I think neither one of these examples is kind of a perfect sector for that, but I think you can imagine other ones where there are kind of these like upstream impacts of reducing intermediary markups. Was there another question? Okay, so let me just very quickly go through, I'm just gonna give you one slide in each of these last three papers. I just think they're really nice examples of, experimental or quasi-experimental results, looking at the impact of competition empirically in low and middle income country contexts. So this first paper is a paper by Busso and Galeana, and they're basically randomizing entry into the grocery store market in the Dominican Republic. One thing that I think is particularly clever here is you might think, how do you run an RCT where you randomize grocery stores? Both how do you convince grocery stores to enter? How do you literally physically build grocery stores? Well, they're not. They're doing something very clever here, which is they basically have sort of these administrative rules around a conditional cash transfer program. So let me kind of tell you the backstory. So this is a conditional cash transfer program in the Dominican Republic. It's providing transfers to poor households. The critical feature for their paper is that these households are getting their cash transfer on a debit card that can only be used at affiliated grocery stores. And so when they say they're randomizing entry, what they're really doing is randomizing entry of existing incumbent grocery stores into this program, this affiliated program. So it's a really clever way, I think, of getting kind of randomized variation that otherwise might be quite difficult to get. So they induce the entry of 61 small retail shops into 72 different markets. They are even able to get variation in sort of the number of new stores here on the intensive margin. And that, overall find kind of a reduction in prices, 2 to 6%, as you expect, more in areas with more entrants. And they see some improvements in self-reported service quality level. Okay, so I just mentioned to say, there's lots of ways to try to, if you want to think about experimental approaches to get randomized entry that don't literally have to be kind of, building new stores. And I thought this was pretty clever. I want to talk quickly about sort of, this is going to be sort of impacts on quality. So this Bjorkman-Nyquist et al. Paper is looking at entry into the pharmacy industry in Uganda. So the backstory for this paper is there's, counterfeit medications, actually a really big problem. So these don't think here of kind of, the CVS or Walgreens that are, regulated by, say, everything's regulated by the FDA. This is a situation where pharmacies in Uganda are these very kind of small mom and pop shops that are sort of unregulated, and counterfeit medication is really a big problem. Okay, so in particular, they're looking at anti-malarials that are medications to treat malaria. And so what they're showing in this paper is entry can matter, and in particular, the identity of the entrant, whether they're high quality or not, can really matter. So they randomly assign the entry of sort of a high quality provider of anti-malarial drugs. Okay, in this case, they're working with an NGO that is a retailer providing basically authentic drugs that are priced at below market prices. And so what they find is that first incumbent prices drop by quite a bit when the entrant comes in. Okay, this is suggested that at least some of the incumbents were initially pricing, above cost. And sort of, I think most interesting, they find basically the share of incumbent firms that are selling fake drugs drops by 50%. Okay, so bringing in sort of a high quality firm can mean that other firms are going to start to match and compete in quality. Right? This also suggests, by the way, that part of the issue, you might have assumed, okay, there's lots of counterfeit medication, but maybe these small mom and pop stores don't know or have no control over their quality. And this is a problem coming upstream. This is suggests at least part of the problem can be ameliorated by the downstream, retailer behavior. And they find sort of these welfare effects you expect to see, which is the overall use of anti-malarial drugs increased, right? So people kind of learn that the quality is better. Okay, so who the entrant is can really matter. The final thing I'll mention is the contracting piece, which I think Rocco already covered, so I won't, cover in great detail, but I just want to mention it because I just want to say that, competition is not always a good thing. There can be much more nuanced effects depending on the broader context in which it's operating, right? So the overall punchline of this paper is sort of, in a second best world, competition might not always be good for consumers. Or in their case, they're looking at monopsony power, so it might not always be good for producers. Let me just give you the quick summary here. This is an environment they're looking at coffee farmers who sell to these mills in Rwanda, and there's lots of relational contracting going on here. So it's actually a pretty complicated contract, but the most basic part is that before harvest, these farmers are super poor and credit constrained. Mills are providing inputs, extension services, which means basically just training and cash loans. And the expectation, the kind of relational part, is they're going to provide that before the harvest, and then post-harvest, farmers are going to sell back to the mill. Okay, and that's how the mill's going to recoup their costs and also basically capture some of the local supply. Now, greater competition among mills, that there's multiple mills that farmers can sell to, that's going to increase the urge to, or the temptation to side sell. That's kind of the ag term that's specific to this, but it's basically reneging on the contract, right? So they're going to have better outside options. It's more easy after the harvest to sell to another firm. That's going to make the mills less willing to give inputs up front, and it's going to make this relational contract harder to sustain. So another very clever way to get exogenous variation in competition. So they don't have randomized variation, but they're going to use an IV approach. So they sort of luck into finding this old engineering model of kind of what areas were suitable for mills that wasn't actually followed in practice. But it can tell them kind of how likely it would be to kind of place a mill in this area, whether it's kind of appropriate given kind of the number of trees and road access and all that. Now, of course, the suitability is going to affect kind of local supply. So they're going to condition on sort of your own suitability for your own placement. And then kind of in a donut IV, they're going to look at kind of a radius around the mill and say, you know, what are you surrounded by more suitable areas, with the idea of you're controlling for all the factors that might affect your local supply. But you're going to get exogenous variation, kind of how exposed you are to other mills. And so what I find mills facing more competition, you know, first they have worse performance. Some of these things like higher unit costs and lower volumes could just be scale effects. Right? So as firms face more competition, they have lower variable profits. If there are some sort of scale effects, they might have higher unit costs. You know, what can't be explained by just scale effects that's pretty critical is they find lower aggregate quantity supplied to the mills. So to all mills basically in the area when there's when there are more of them. They also kind of critically find, you know, fewer relational contracts, right? So those do seem to break down, and farmers seem to be worse off as well. Okay, so they're seeing basically sort of they're selling less to the mills and they're seeing lower overall revenues. So just say the effects of competition can be quite nuanced. Let me conclude by just talking very brief about kind of opportunities for future research. So first, specifically on this question around competition in the low and middle income country context. So we've talked about lots of the challenges, right? So there's limited record keeping, especially for these smaller firms. Kind of the joint nature of kind of household run enterprises make it very difficult to separate supply and demand shocks in a lot of contexts. There's also, you know, kind of this history, I think, of distinct methodological approaches from the development literature and from, say, IO, for example. But that also means there's a lot of opportunities. Okay, so I should say just this distinct methodology, your ears should kind of perk up if you're a PhD student. You know, I think this is an area where I think lots more work can be done. And I think in particular, I think especially in development, there's lots of unique opportunities. Okay, so first of all, we saw an example in that paper that I have Michael, you know, you can experimentally estimate a lot of these key features from the standard IO approaches, right? So for example, experimentally estimating demand, that's going to allow you to, you know, first of all, overcome this issue around kind of getting separating supply and demand shocks. But even relative, which I think is critical in the developing context, but even relative to kind of the general IO literature, you know, you're going to get around a lot of those typical, I think, fairly strong identification assumptions. So there's lots of opportunity here for kind of experimental work in this space. And then my kind of final broader pitch I want to make is that, you know, you can, I think, partially because many of these markets are so isolated and small, and certainly not all, but in many kind of developing country contexts, it means that if you want to do experimental work, you can actually get exogenous, sometimes even randomized variation at a market level in ways that I think can be more difficult in wealthier and often more integrated markets, right? So you can get variation in entry and competition at a market level, and that can be really useful. And so I want to just conclude by kind of that broader pitch of like market level experimentation. And I'm going to talk about RCTs, but I think you could also imagine quasi experiments as well. This market level experimentation is useful not just for measuring effects on competition, but really any outcome that's going to have a market level effect. So trade cost, migration, you know, relevant to this course is really any intervention I think that you've talked about from the policy perspective, trying to alleviate, you know, labor market constraints, capital market constraints, you know, all those interventions, their impact is going to depend on how firms in the market are interacting. Right. So even the case, for example, the classic case of microfinance, you might see if you give a loan to a firm that they expand their revenues, but is that sort of truly new productivity and production, or is it business stealing from other firms? That's a really kind of classic question. And so, I want to just emphasize there's sort of been this recent push to do kind of this market level experimentation. Again, I'm talking mainly about experiments, but you can imagine thinking about natural experiments as well. Just to highlight a few, randomized saturation and migration incentives. I've got some work randomizing a reduction in search cost. I mentioned before kind of this microcredit thing. There's this really nice paper by Jing Kai and Adam Seidel basically randomizing the saturation of loans across firms. And they do actually find a good deal of kind of this business stealing happening. Randomized saturation of cash transfers, business training, et cetera. So this is kind of, if you note the dates in all these papers, they're all pretty recent papers. I think this is a really exciting but new place that the literature is going. And so I would love to see your paper here next. So I got one more minute. Let me ask a question by Timothy.
Lauren, I'm just interested in your perspective on the most interesting thing to learn next, whether why more firms don't enter or why more firms don't leave.
I don't know that I'd say one is more interesting than the other. I do feel like we focused a lot on the first question about why more firms don't enter and not much about why firms don't leave. I mean, that's also true, I think, from kind of the micro friction. I think a lot of that comes from, that statement is really specific to the development literature. And a lot of the development literature has been very focused on, I think, questions that feel more easy to tackle, like, questions where you can randomize loans to individual firms to see if that helps them to enter, for example, or potential firms. I think now more and more with kind of this market level experimentation, we can try to get variation of the forces that might also discipline the market and lead to kind of proper weeding out. I should say there's a whole trade literature, looking at this question that's done it kind of from a trade perspective and looking at kind of market level outcomes. But I think on kind of the micro frictions, we've focused a lot on the question of entry. And I think that's really been driven a lot by kind of what we can get a handle on methodologically. And as these sort of new approaches kind of open up, I think we'll be able to say much more about the latter.
Thanks.
I should probably stop here. I know we're out of time. I was requested to give you one more reminder that the last lecture is tomorrow, and it is, Dave, you'll have to remind me, the lecture for tomorrow is
Rekha Uhas is going to be talking about industrial policy, a nice round out to the whole course. Thank you so much, Lauren. That was fantastic. And we're so excited so many of you could join us, and we're excited to finish the course tomorrow with another blockbuster lecture. So thanks again, and see you all tomorrow.
Thanks, everyone.
Thanks, Lauren.